In this next series of videos, we're going to look at sampling. And as we talked about in the prior videos, the whole purpose of all of this statistics and study design is to examine relationships between events, namely between exposures and outcomes, causes and effects, looking to see if one thing, like getting lung cancer, is dependent on something else. So the group of people that we are interested in seeing if this relationship exists in that group is the population. So this group of people often is quite large. It might be the entire population of the world or the entire population of the United States or some other country. And it may be impractical or impossible to look for this relationship in this gigantic group. So what do? We take a sample. We take a small portion of this group. And this smaller group is probably a much more manageable number in which we can look for that relationship. So now, the question becomes, how do we pick? How do we pick which one of these people we're going to put into our sample? Well, our goal is that this sample looks like the population. Therefore, if we see this relationship here in the sample, we can say, that relationship probably still applies in the entire population as well. So we want this sample to look like this population and all the important factors, and what we call that is representativeness. So let's say that we have a population which is 50% men and 50% women. So that's our population. And then we take a sample, and then we get one conceivably that is 75% men and 25% women. Now, this sample does not represent the population. Look, there's way more men in here than there are in the population. There's way too few women. So this would obviously skew any data that we have in favor of the men, whereas in reality that might not be the case. So how can we guarantee that we get a representative sample? Well, we can't guarantee it, but we can increase the odds of it, and that's what we're going to talk about in these next few videos. The first thing that we're going to look at is probability and non-probability samples. So in probability samples, we look at the entire population here, and everybody has a chance, a non-zero chance of being included in the sample. And we could calculate the probability of that chance, and there's some element of randomness in who gets selected. Now, the one thing I want to say is, even though everybody has a chance, we're not saying here that everyone has the exact same chance. Now, the fact that there is an element of randomness here allows us to use inferential statistics and descriptive statistics, but that inferential statistics is the key part, the powerful piece of this. Now, conversely, a non-probability sample is not going to meet those criteria, so there might be someone who has no chance of being included, or we can't calculate it, or there's no element of randomness. And so what this does is it makes us unable to use inferential statistics. We could still do descriptive statistics, things like reporting on the mean, the median, the interquartile range, the standard deviation, but we can't do those things that let us make assumptions, like what is the probability of this happening. So there are different kinds of probability samples, and we'll go through all of these. Unfortunately, most of them have the initials SRS. And there are also different kinds of non-probability samples. We will be focusing mainly on the random samples. Now, one point of order I want to make, and that is that randomness does not automatically guarantee representativeness. And I'll give you two examples. Let's say we had a population of 500 men and 500 women, and we took a sample of 10. Now it's conceivable, if we took a random sample, we randomly picked from within this population, that we would get 7 men and 3 women. It's also possible you might get 1 man and 9 women. And while these were randomly chosen, this does not represent this 50-50 mix. This one doesn't, and this one doesn't. So again, randomness does not guarantee representativeness. Now, we can improve our chances by taking a bigger sample size. Let's say instead of taking a sample of 10, we took a sample of 100. So the chances of getting 70 and 30, it's much less. You're probably going to get something more like 54 and 46. And the chances of getting 10 and 90, that's pretty slim as well. So the bigger the sample size, the more likely that you're going to have that randomness is going to lead to representativeness. But it doesn't necessarily guarantee it. The other place that I always see this is when I set my MP3 player to shuffle mode. Now I've got 13,000 songs in there. It could play straight for 41 days and not play the same song twice. Yet it always seems to pick songs by the Beatles. And the Beatles probably consist of 1% of my collection. It is picking it randomly. It's just not making a representative sample. But if I were to let this play out over days and days, I would find that it probably, and that thereby increasing my sample size, I would note that it would probably be more representative. So this is our quick introduction to sampling. Now we'll look at examples of some of these in the next few videos. Okay, see you there.